Experiment number 17, 3-phase motor with wound rotor, 2 poles, 42 volts. Here we require AC stator, ring rotor and brushes. Now, and this is the circuit diagram which we have to make for slip ring motor. So first we make the circuit diagram, and here we have to initially there was squirrel cage rotor inside. So now we will put wound rotor, slip ring rotor inside this AC stator, and we will use these brushes for slip ring rotor. We have connected the circuit as per the diagram. Now, in the diagram we can see 42 volts supply is required. So we have selected 42 volts, and for excitation of electromagnetic brakes 0 to 8 volt is required. Now we switch on the supply. The motor starts running. At this position the RPM is around 1800 and complete resistance is inserted inside this machine. Inside this, these are the wires from slip rings. Now complete resistance is inserted. I remove one set of resistance and the speed increases to 2300 RPM. Again we cut the resistances and the speed increases. This is around 2600 RPM. Now at last the rotor is shorted and the speed is around 2000 RPM, 3000 RPM. So this is how in wound rotor machine the rotor resistance, effect of rotor resistance comes in the circuit. Again, for this purpose, if we want to load this motor and draw the characteristic curves, show the loading of motor, we will do the procedure. We will excite this electromagnetic brake through the 8 volt supply, and we can see with increasing the DC supply over there, there is increase in torque. And the speed is also decreasing with application of torque. So this was all about wound rotor machine. For the characteristics of motor, we have to load the motor up to 0.67 Nm. For every step we have to measure voltage, current, power 1, power 2, addition of power 1 and power 2, cos phi we can calculate using formula. N is the RPM, P is the output power which we get from the formula, and efficiency which we get from the formula. So we have to first tabulate these quantities and then make a graph out of it. Now we will make 3-phase synchronous induction motor, 2 poles, 42 volts delta. For that we will require AC stator with ring rotor and brushes, power supply, electrical measurement unit, mechanical measurement unit, adapter support, starting rheostat and synchronizer, electromagnetic brakes. So for that we have to make connections like this. First we make the connections. Now we have connected the circuit as per the diagram, and we have to keep this knob at RA1 and this knob at up to 80% of the value. Now as we know that we want 42 volts, so we select 42 volts and we start the machine. The machine has started. Now we will decrease the resistances like this, and finally we will put it on the last option. Now we can see the machine is synchronized. This is a 4-pole machine, so machine is synchronized to 300. It is running on 3000 RPM and it is synchronized to the supply frequency. We can see the values of voltage and current here, and also this is the DC current, this is the excitation current, this is armature current. Now we will, using this knob, we will move the current. We can see by increasing IE, by increasing excitation, the armature current is decreasing. See, the armature current is decreasing with increase in excitation, and at a point come, say this is the point where it is a minimum. Now if increase further than that, the armature current again increases. It increases again. So it is making a V curve. We can see now I decrease the IE, excitation current. One can see that armature current is decreasing. This is the normal position where it is a minimum, and if I decrease further, it will increase again. So at 0.99 there was a, so at 0.99 it was a valley, and after that it started increasing again. So this was V curves of induction motor. This is how we draw V curves of induction motor. Next experiment is 3-phase synchronous induction motor, 2-pole, 24 volt. So the connection diagram, we have to change only this connection diagram, rest all is the same. So I humbly request the students to make this connection and do this experiment by their own. It is same as the previous one. Now we will do experiments on DC machine. Experiment number 22, DC motor with separate excitation. For this we will require DC stator and commutator, rotor and brushes, power supply, load and rheostats, electrical measurement unit, mechanical measurement unit, adapter support and electromagnetic brakes. So we have used DC stator, DC rotor with commutator and brushes. So we have coupled this unit with electromagnetic brakes. Now We will connect the circuit for separate excitation as given in the diagram. We have connected the circuit as per given in the diagram. Now here we have to want 42 volt DC. Now if we switch on, the machine starts rotating and it is giving RPM 3000 RPM. These are the DC parameter. Upper parameter is for we can see DC voltage is 48 volt, DC current is 0.9, field current is 0.8, field voltage is 33 and RPM is 3000. Now initially it was kept at B. We have decreased the resistance to A. If we want to increase the speed more, we have to move this field rheostat. This will increase the RPM. So if we want to increase the RPM using field, we see that a field current is decreased, field current is increased, RPM is decreased, and if field current is decreased, RPM increases. So this is the phenomena that field current is, speed is inversely proportional to the field current. Same wise for armature voltage, if we decrease the armature voltage, speed also decreases. I am decreasing the armature voltage, field is also decreasing. If I increase the armature voltage, speed increases. So we have to make a table out of it. Next is DC motor with shunt excitation. It is having only just one change and remaining is the same as we have done in the previous experiments. Now we will go for DC motor with series excitation. So for series excitation, the experiment is to start the DC motor with series excitation, invert the rotation direction of motor, operation characteristics of the motor, and connection diagram we have to make is like this. So first we make the connection diagram. Now we have made the circuit for series winding. And here, as per the diagram, we have to select 32 volts. So we have selected 32 volt DC. Now we switch on the supply. As we switch on, the motor starts running. As it is series machine, it will run on very high speed, and we can see that RPM is around, it will increase gradually. Nearly 3500 RPM it is running. Now with the same method for loading the machine, we will use the electromagnetic brakes and we will excite the braking. As we excite the braking, the torque increases and the RPM decreases. As you can see, torque is increasing, RPM is decreasing. So likewise we have to make a graph by tabulating all these data and make a graph. Next experiment is DC motor with compound excitation, long shunt. We have to follow the same procedure. By using this diagram, we have to make a connection same as given in the diagram, and then we'll run the motor, and then we'll put the loads on the motor to get a table like this. So it is the same as we have done in shunt machine. Even DC motor with compound excitation, short shunt, we have to make the circuit as per the diagram and run the machine. All the procedures are same as we have done in the shunt machine exercise. Now there is one special kind of motor, single phase series motor. For single phase series motor, we will require DC stator and commutator rotor brushes, and we will make the DC single phase series motor out of it. This single phase series motor is what we have in our Tulu pumps in home. We have connected our machine as per single phase series motor. Now we will run single phase series motor. For that we will require 24 volts. Now we on the machine. See, this machine has started. The RPM is gradually increasing. This is the voltage and current. This is called series machine. For loading, we have to do the same method what we have done in previously experiments by loading it to the electromagnetic brakes. Next is repulsion motor. This is the diagram for repulsion motor. We have to connect the diagram for repulsion motor and do the experiment as we have done previously in the case of series motor. So it is like same. So I request the students to do it by yourself only. Now we will make a connection for no load test of synchronous. We will make now for experiment 30, we will go for no load test of alternator. For that we will require AC stator with ring rotor and brushes, DC stator with commutator rotor and brushes, power supply, electrical measurement unit, mechanical measurement unit, and loads and rheostat. And for that we will make the diagram as per given in the manual. This is the diagram which we have to make. So here we have used AC stator, ring rotor, DC stator and commutator rotor. All are coupled together. And now we will go for no load test of alternator. So first we make the connections as per the diagram. Now we have made the circuit as per this diagram for no load test of synchronous generator. Now we will start the motor and take the readings. For that we want 32 volt DC The motor has started running. As we can see, this is the current for the motor, this is the field current of generator, and this is the generated voltage. Now, using this rotary switch, we will increase the field current, and with the increase of field current, the generator voltage will increase. With the increase of field current, the generator voltage will increase. One can see here, we are increasing the field current and the generated voltage is increasing. We can make it up to 40 volts. See here, field current is increasing and generated voltage is also increasing. So this will call the no load test of the synchronous generator. Now after that we will do short circuit test of synchronous generator. For no load test, we have to make graph between excitation current and generated voltage. We can take the excitation current up to 10 amperes. After taking no load test, we will do for short circuit characteristics. For short circuit characteristics, we have to make a circuit. We have to make a circuit as shown in the figure. So we have connected the circuit as per diagram for short circuit characteristics of the alternator. So here we will get the field current, excitation current, and here we will get the armature current or the AC current, short circuit current. We have to take readings as per this table, and excitation current can be increased up to 10.5. So we start the motor and keep this excitation at the lowest. Now I start the motor at 32 volts. One can see this is the excitation IE and this is the armature current or the alternator current. So now I will increase using this knob. One can see with the excitation the alternator current increases. We have to make the graph between IF and IK. Like this we will find the short circuit characteristics of the synchronous generator. After that